Okay, factoring ax² plus bx plus c. Now, normally, I used to break it up and say when a was equal to 1, and then when a was not equal to 1. But thankfully, I learned a lot from my students, and I learned a couple different methods, to whereas it doesn't matter if a is equal to 1 or a is not equal to 1. One key thing to remember, though, is that factoring will give you rational exponents. Not exponents, but rational zeros only. We had a problem in class where we could not factor the problem, but we found it had 2 zeros, but those zeros were irrational. If this is the case and you can't factor, you have to go to the quadratic formula. Or a calculator to find your zeros. Now, here's the method. It is extremely straightforward, pretty simple, and it works as long as you can factor the problem. First step, a equals 3, b equals -8, c equals -4. You're always just going to take the coefficient. There's a, there's b, and there's c. And if there's a negative sign or a plus sign, you're going to bring that out too. Now the second step is you're going to take a times c, which we have 3 times -4, which is equal to -12. Now, the third step, first off, those two steps are pretty straightforward. We're going to find two numbers that multiply to get us to the AC, which is -12. But when we add them, since we're dealing with the middle term, they have to be equal to b, which in this case is a -8. So you think, this is where you have to make your decision. All right, I got a -12. I think, all right, what two numbers are going to have a difference of 8? And I have AC as a -12, so I need positive times negative. And we'll see if we could get this to work. In this case, you get 3 times -4, -4 times 3, 2 times -6, -2 times 6. And in this case, we're not getting any type of love out of this. So I'm going to cheat a little bit, and I'm going to say this is actually +8, that's a +8, that's a +8. I'm going to say that's a +4, that's a +12, that's a plus, that's a plus, because then it'll work out really good. Alright, so now we skip that because I changed it. I need two numbers that multiply to get to a +12 to get to a +8. I can change it. I'm the math teacher. We're good to go. And hey, 6 times 2. 6 times 2 is 12. But 6 plus 2 is 8. So we're good to go. So now, I found my two numbers. I'm going to make a box. I'm going to make a box, and I'm going to take the first term, 3x squared, and I'm going to put that in the first part of the box. The last term, +4, I'm going to put in the last part of the box. And now I'm going to take these two numbers, the 6 and the 2, and I'm going to say that's 6x and that's 2x. And now what I'm going to do is I'm going to factor the rows. The first box's sign, positive or negative, tells me which or what the factor sign is. So, since this is positive, I know I'm going to get a positive. I have 3 and 6. Factor that out, you get a 3. X squared and x, we get an x. Now here it's positive, so I know it's going to be positive. 2 and 4. I'll get a 2. X and nothing, well, I'm done there. What this does is this gives me the binomial 3x plus 2. Now, I'm going to factor the columns exactly the same way as I factored the rows. So I take the top column, 3 and 2, nothing. Nothing can divide evenly into 3 and 2. X and x squared, I can take the x. You're always going to get an x in your first term. Now, I have a positive 6x here. Sometimes I like to just put positives with my middle terms, so I know if it's positive or negative. So I'm going to get a plus. 6 and 4, common factors of 2. And x and nothing, so nothing, so I get x plus 2. So y, if y is equal to 3x squared plus 8x plus 4, this is going to be equal to 3x plus 2 and x plus 2. And if we want to multiply this out, 3x times x is 3x squared. 2 times x is plus 2x. 3x plus 2, that's plus 6x, which is going to give me 8x. So I have 3x squared plus 8x, which is right there, and then the last 2 is plus 4. Works out. Now, the whole reason why we want to factor is we want to get zeros. So, to find my zeros, which in this case are going to be rational, I'm going to take that 3x plus 2, the first one, set it equal to 0. I'm going to take the x plus 2, set it equal to 0. Solve for x in each case. Subtract 2. Negative 2 equals negative 2. 3x is equal to negative 2. Divide by 3. Divide by 3. X is equal to negative 2/3. So, this is a 0. Subtract 2 from both sides. X equals negative 2. This is another 0. So if I really wanted to, I could say, alright, 1, 2, 3, that's negative 1. 1, 2, 3, that's negative 2. Negative 2/3 would be right there, and negative 2 is right there. Those are my two zeros. I know it's 3, so I know it's opening up, so I know it's going to go that way. I know it's going to go that way. And then I'd have to find the vertex down there somewhere. We could use a calculator for that. But this process, even though I started with negatives, I changed it to positives, just so it works out nice and neat. It works for even the most difficult ones. It is easier if a is 1. But it works for all of these. Here's a key, though. Factor out common factors. First. Factor out your common factors first, because otherwise the process doesn't work. So, that's it.